Hi everyone. In this video, we are going to understand why do we even need reinforcement learning for LLM reasoning. So, before we understand the nuances of reinforcement learning and the elements of reinforcement learning, we should have the intuition that what was happening before in with regards to LLM reasoning that that reinforcement learning was able to solve. So, in order to do so, let's understand that how naturally an LLM is trained. When an LLM is trained, we know that we first create a base model of the LLM. The base model is just the next token predictor. It has no understanding that what is the ideal way to answer to the user. So for that we use supervised fine tuning, in which we provide pairs of the prompt and the ideal responses, and the LLM is then trained on top of those ideal responses. So once the LLM has been trained on those ideal responses, now the LLM is able to answer in a certain way because it has been trained. And the model, the bare trained model, I would say, is called the base model. And after training, it is called the assistant model because now it answers to the questions in a assistant's way. For example, if you will directly ask the LLM what is 2 plus 2, it is going to directly put the answer in front of you, that is 4. But after it training, it is going to give you response like the answer to your question 2 plus 2 is 4. So it is going to build a preamble before answering to you. So this is basically how a supervised fine tuning works. I am sure you already know that. But can we use supervised fine tuning to induce reasoning behaviors into LLM as well? Good question. Yes, supervised fine tuning can be used to induce reasoning into LLMs, but is it the best way to do so? No, it's not the best way. It actually depends upon the condition, it depends upon the situation. Based on the situation, you might want to use supervised fine tuning, or you might want to use reinforcement learning. The DeepSeek team, when they first started working on reinforcement learning, they created their model, the main model. They instilled reasoning into their main model via reinforcement learning, but for their smaller models, they distilled reasoning into them via supervised fine tuning. So you can say they use both supervised fine tuning and reinforcement learning for reasoning, but let's understand that how do they differ. So in traditional supervised fine tuning, in order to instill reasoning into the responses of the LLM, what I'm going to do is that I'm going to create hundreds and thousands of pairs of the ideal responses. So if my question is what is 2 plus 2, I'm going to create a very step by step solution based response for it, and I'm going to train my LLM to answer the question in such a way. One example is given here, that we need to train the algorithm via supervised fine tuning. The question is solve 17 into 24. So this is the ideal prompt. This is the ideal response that we give to the LLM to train on. So the LLM sees that I need to answer in a step by step way. So after it has been trained on millions of such examples, it will know that whenever I am given a math problem, I need to create the response in a step by step way. So it is going to, whatever math problem you are going to give it after supervised fine tuning on such a data, it is going to answer it in a step by step way. But if we suppose that while it was creating the steps for the problem, or we can say that while it was trying to imitate the trying to imitate the human on the data of which it was trained, and it makes a mistake. So rather than 17 into 4, it does 17 into 3 and gets into the wrong answer. What is 17 into 3? 73. It's going to be 51. So it makes a mistake here. Rather than doing 17 into 4, it did 17 into 3 and calculated 51. Now instead of realizing that it has made a mistake and then improving its response, that is making the mistake right, it is going to continue. It will never understand, it will never know that it has made a mistake, and it will continue with the mistake. So now that if it has done 17 into 3 is equal to 51 instead of 68, we will have 51 here, and 340 plus 51 is going to be 391, which is the wrong answer. But the LLM never knew that it made a mistake here, and eventually because of this mistake the response it created is wrong. It is very confidently going to hallucinate and going to tell you that 391 is the correct answer. So this is the problem with supervised fine tuning, that there is no inherent sense of reasoning in the LLM itself. It is just trying to imitate the behavior of the ideal prompt response pair we provided it. It does not know that uh, what it means to multiply two things and then get the answer, and how do I recover from a mistake that I make. It is just trying to imitate the step by step behavior it has been taught. Now obviously when the LLM is trying to create a step by step solution for a particular problem, there are chances that everything that it is going to do in the step is going to be correct, because at the end of the day these are very powerfully trained LLMs, and they have been trained on millions of instances of data. So their chances of hallucination and making mistakes are correct. But the problem with supervised fine tuning is that if it makes a mistake, there is no way for it to identify it and then correct itself. Whereas in reinforcement learning, it can identify it as a made a mistake and then it can correct itself. So let me show you the aha moment of reinforcement learning for LLM reasoning. So here you see the DeepSeek team was trying to train a reasoning LLM via reinforcement learning, and they gave this question to the LLM, and the LLM started to generate responses for it. But while it was generating the responses, it realized that it has made a mistake, or sometimes it realizes that there is an even better way to solve the problem. And from there on, it is not continuing with the mistake that it made. It is actually re-evaluating it step by step and is moving towards the correct answer. But in supervised fine tuning, we saw that it cannot understand that it has made a mistake and it cannot recover from a mistake. But if we are training it via reinforcement learning, while it is working, while it is generating the response, it can understand that I have made a mistake, or while it is generating a response, it can understand that there is a better way to do this particular problem and it can correct uh, its trajectory. How this happens, we are going to see it when we are going to understand PPO. In PPO, you are going to see that how for each token it gets reward. So it knows that the token I am generating are good or not. But as you can see, the in the middle of the response, there was an aha moment for the LLM that made it understand that I can do better from here. I should do something other than what I was already doing in the response to this prompt. So yeah, it is an interesting aha moment of an intermediate version of DeepSeek R10. So R10 was their first attempt to create a reasoning LLM. The model learns to rethink using an anthropomorphic tone. This is also an aha moment for us. Indeed, it was an aha moment for us mere mortals, for us humans as well, that we can instill reasoning behavior into the LLMs. So yeah, it can allow us to witness. So yeah, this example allowed us to witness the power and beauty of reinforcement learning in LLM reasoning. So this is, my friends, how reinforcement learning. This is why reinforcement learning is important for LLM reasoning. We understand that what are the limitations of supervised fine tuning, and we saw that how reinforcement learning can solve the limitations of supervised fine tuning.